Hey, have you been curious today? What comes up in your mind when someone brings up Lego or Minecraft? If I were a kid, I would be super excited. Well, I still get pretty excited because I'm kind of like a big kid. For those of you not familiar, one can unleash their creativity and build amazing structures from small fundamental building blocks, with Lego by hand and Minecraft via a computer. On that note, do you have any interesting stories about creating your own world with building blocks? Now, what if there's a real-life version of these building block games? What I mean is actually building the stuff around us, and perhaps creating new and interesting ones to help make a better world. The thing is, there actually is one. And I'm not kidding, but many of us just haven't really paid too much attention to it. The rules of the game, however, are much more complicated than Lego or Minecraft, but the stuff created from it is way cooler, and the possibilities it offers are surely a lot more epic. So what is it? Let's keep watching to find out. Imagine that when you put together some Lego bricks in a certain way, the structure you built glows. But if you connected some different bricks together, the structure you have now stops glowing but it gets hot. Or if you use some other bricks and connect them together in a certain way, you now have a machine that can use sunlight to turn carbon dioxide, which is typically considered a waste, and water into vodka or other useful fuels, while releasing some oxygen along the way. How cool is that? It might sound like I'm making stuff up, but there really is alcohol made from CO2, and scientists around the world are working really hard to find a way to efficiently turn carbon dioxide into fuels that we can use for our lives. How is that possible? The world around us, including yourself, the stuff you use every day, are all actually made from tiny fundamental building blocks. But the types of blocks and their complexity greatly outnumbers that for Lego bricks. What's interesting is that depending on the type of block you use, the number of blocks you use, and the way you connect them together, you don't just get for Lego a cool structure that you can only display, or for Minecraft stuff that's limited to being inside a computer, but instead a real thing that has its own unique properties, which can be used to help make our lives easier or to help contribute to a better world. Since CO2 and water contains the types of building blocks needed to form vodka or other useful fuels, it makes sense that we can try to find a way to take the blocks that form CO2 and water to build other things that we need, like some booze or jet fuel, right? These building blocks are actually what we call atoms. And different kinds of these building blocks are what we call elements. Through experimentation and reasoning, the characteristics of different elements were organized into a table so that people later could have a handy reference to refer to when they want to deal with these building blocks. That reference is a table that some people love, yet many others fear, the periodic table. Don't worry, I'm not going to talk about the periodic table or how cool the different elements can be in this video. In fact, there's a veteran YouTube channel already dedicated to that. So go check them out if you haven't yet. I actually want to chat a bit about chemistry beyond the elements and cool flashy reactions, because it's so much more than just that. My feeling is that when many people hear the word chemistry, one might only think of visually entertaining reactions or transformations, while others might low-key in their minds probably go like this or this. Chemistry might be so scary or intimidating, perhaps because of unfavorable experiences from class, complicated names of different compounds, negative messages about it as something used to create unnatural products or processes that benefit corporations at the expense of regular consumers, or the feeling that it's just something that's studied by scientists hidden behind the closed doors of university and industrial labs. But a large part of chemistry is like the building block metaphor that I brought up earlier. What I want to get across is that all the stuff around us, including your body, are made out of tiny building blocks. And there's so much we can learn and do and create with these tiny building blocks. And that's really what a large part of chemistry is about. To bring this a bit further, here are some real-life questions to think about. Why does water form tiny spheres on a waterproof jacket while it soaks right into a regular hoodie? How can we make something that behaves like plastic when we use it, but doesn't persist in the environment and become pollution, and instead degrades and becomes part of the soil? Where does the flexibility of an elastic band come from? Why is it so hard to wash away grease with water? But when we add some detergent, it becomes easier. What are food additives? How do they work? And what effects might they have on us? If you understand the rules of how different atoms and molecules connect, as well as the relationship between structure and property, know what makes up something at the molecular level, and have the passion to create something new, you have the strength, ability, and insight to either quickly answer these and other problems, or have a lot of fun trying to figure out a hard problem. Also, there's another thing I want to mention. It's true that people can and have created terrible things using knowledge of chemistry. For example, DDT or chemical weapons, but it's a direction that we really shouldn't head in. Instead, we can also focus on using knowledge on how to piece together these building blocks to create something that will help make our communities and our world better, or simply learn more about how our world works, and if fortunate enough, share it with others and help advance the collective human knowledge on this. For example, the human body, in fact, is a superstructure exhibiting tons of amazing functions. The current form of how it's put together developed over a very long time through evolution in nature. The complexity of the machinery that makes up our physical selves is fascinating and beyond the imaginations by many of us, with so much that we don't know about yet. Or how nice would it be if one can find a way to build something that efficiently turns CO2 into something useful? So what is chemistry? I mentioned earlier that a big part of it involves building stuff from fundamental building blocks. To be a bit more formal with the terminology, this part of chemistry is known as synthesis. In simple terms, it's basically figuring out how to make something new from available materials that you can find around you. For example, the reasons that we have medicines to help us feel better and recover when we're sick has a lot to do with developments in synthetic chemistry over many years. But like I mentioned earlier, this is only part of chemistry. The rules of the building block game in nature are a lot more complicated than that of Lego or Minecraft. If one simply just puts different combinations of things together to find one that works or is useful, that's pretty inefficient, right? And it could also be really dangerous. So, to learn the rules of the game, we have to understand the physical part of chemistry. Here one tries to answer questions about how different atoms of different elements combine together, why they combine together in some specific way, and for the product we get, why it has the properties it has. At the scale of atoms and molecules, things function quite differently than in the world that we're used to in our daily lives. And so we need to spend quite a bit of effort to understand how things work at that scale, as well as how it translates to the properties that we observe. Finally, operating at the scale of humans, how do we figure out what elements are in a material, how they're connected, and in general, how can we accurately work with and detect what we have on hand? After all, two transparent solutions can be made up of completely different things. Here, we deal with analysis in chemistry. Analytical chemistry tries to answer those questions. Much of the process deals with finding methods on accurately detecting the stuff we have, which can also involve working with and developing cool and fancy instruments. To sum up, chemistry basically involves studying the physical matter that we find in this world and trying to answer questions about their characteristics and properties. With respect to this, it's kind of like a complicated building block game, where we can try to find new or better ways to build things, figure out what stuff is made of, as well as ask and answer questions about the rules of the game. With the 3 points I mentioned above being synthetic chemistry, analytical chemistry, and physical chemistry. But what about organic, inorganic materials, electrochemistry, and other such and such chemistry that you might be more used to hearing about? I'm not trying to say that subdivisions of chemistry can only be classified as synthetic, analytical, or physical chemistry, but I've come to realize within all the divisions of chemistry that chemists are currently familiar with, don't we all deal with some form of synthesis, analysis, or studying the physical? Bearing that in mind though, chemistry is actually a very interdisciplinary subject. Not only between the traditional divisions as we know today, but also reaching well into the other sciences as well. For example, as we explore the nature of atoms, molecules, and chemical bonding, the boundaries of physics and chemistry can become not so apparent anymore. Also, because of water, we have biology, and within bioorganisms are numerous complex yet fascinating chemical transformations. Here, we can start to enter the realm of biochemistry and the medical sciences. Not only these, there are tons of other connections that chemistry can make with other areas of science as well. To me, chemistry has come to be more of a perspective that we see this world. But as to what that means, let's leave it to another video.